Hello guys, welcome back to my channel. As you know, I am Vic. Today I'll be talking on a topic from the subject computer graphics and fundamentals of image processing. And as you know, the subject code is 21CS63 in the VTU. So the raster scan displays. The electron beam is swept across the screen one row at a time from top to bottom. It moves across each row. The beam intensity is turned on and off to create a pattern of illuminated spots. This scanning process is called as refreshing. Each complete scanning of a screen is normally called a frame. The refreshing rate, called the frame rate, is normally 60 to 80 frames per second or described as 60 Hz to 80 Hz. So this is a diagram of the raster scan displays. Picture definition is stored in the memory called the frame buffer. This frame buffer stores the intensity values for all the screen points. Each screen point is called a picture element. Property of raster scan is aspect ratio, which defined as number of pixel columns divided by number of scan lines that can be displayed by the system. So there are two cases in this raster scan displays. The case one being in case of black and white systems. On black and white systems, the frame buffer storing the values of pixels is called a bitmap, and each entry in the bitmap is a 1-bit data which determine the on, that is 1, and the off, which is 0 of the intensity of the pixel. So let's move on to the case 2. The case 2 is in case of color systems. On color systems, the frame buffer storing the values of the pixels is called a pixmap, though nowadays many graphic libraries named it as bitmap. Each entry in the pixmap occupies the number of bits stored present in the color of the pixel. For a true color display, the number of bits for each entry is 24, that is 8 bytes per red, green or blue channel. Each channel, which is 28, is equal to each channel 28 is equal to 256 levels of intensity value, that is 256 voltage settings for each of the red or green or blue electron colors. Now let's understand about the random scan displays. When operated as a random scan display unit, a CRT has the electron beam directed only to those parts of the screen where a picture is to be displayed. Pictures are generated as line drawings, with electron beam tracing out the component lines one after the other. For this reason, random scan monitors are also referred to as vector displays, or stroke writing displays, or calligraphic displays. The component lines of a picture can be drawn and refreshed by a random scan system in any specified order. So this is a random scan display diagram. A pen plotter operates in a similar way and is an example of a random scan, which is hard copy device. Refresh rate on a random scan system depends on the number of lines to be displayed on that system. Picture definition is now stored as a set of line drawing commands in an area of memory referred to as the display list. Refresh display file, vector file, or display program. To display a specified picture, the system cycles through the set of commands in the display file, drawing each component in turn. After all line drawing commands have been processed, the system cycles back to the first line command in the list. Random scan displays are designed to draw all the component lines of a picture 30 to 60 times each second, with up to 100,000 short lines in the display list. When a small set of lines is to be displayed, each refresh cycle is delayed to avoid very high refresh rates, which could burn out the process. Now let's understand the difference between the raster scan system and the random scan system. The base of difference being electron beam. In the raster scan system, the electron beam is swept across the screen one row at a time from top to bottom, whereas in the random scan system, the electron beam is directed only to the part of screen where a picture is to be drawn. In terms of resolution, the raster scan system's resolution is poor because the raster scan system, in contrast, produces zigzag lines that are plotted as discrete point sets, whereas in the random scan system, its resolution is good because this system produces smooth lines drawings because CRT beam directly follows the line path. In terms of picture definition is stored in the raster scan system as a set of intensity values for all screen points called pixel in a refresh buffer area, whereas in the random scan systems, picture definition is stored as a set of line drawing instructions in a display file. Realistic display. The capability of this system to store intensity values for pixels makes it well suited for the realistic display of scenes containing shadow and color pattern. Whereas the random scan display, these systems are designed for line drawing and can't display realistic shaded scenes. Whereas in terms of drawing an image, the raster scan display can display screenshots or pixels are used to draw an image, whereas in the random scan display, mathematical functions are used to draw an image. So now let's discuss about color CRT monitor. A CRT monitor displays colors pictures by using a combination of phosphors that emit different colored light. It produces range of colors by combining the light emitted by different phosphors. There are two basic techniques for color display. One is beam penetration technique, the other one being shadow mask technique. So let's move on with explaining beam penetration technique as well as shadow mask technique. So let's start with beam penetration testing. So this technique is used with random scan monitors. In this technique, inside of CRT coated with two phosphor layers, usually red and green. The outer layer of red and inner layer of green phosphor. The color depends on how far the electron beam penetrates into the phosphor layer. A beam of fast electron penetrates more and excites inner green layer, while slow electron excites outer red layer. Now let's discuss about shadow mask technique. So what is this shadow mask technique? It produces wide range of colors as compared to the beam penetration technique that we discussed in the previous slide. This technique is generally used in raster scan displays, including color TVs. In this technique, CRT has three phosphor colored dots at each pixel position, one dot for red, one for green, and one for blue light. This is commonly known as dot triangle. Here in CRT, there are three electron guns present, one for each color dot, and a shadow mask grid just behind the phosphor coated screen. The shadow mask grid consists of series of holes aligned with the phosphor dot pattern. So this ends my presentation. Thanks for watching.